exciting to learn about the processes that you use in your designs. And the next speaker, Sara Akbari from Sara Hadid Architects, is also going to talk about technology and the design processes. So let me just say that Sara is an associate director at Sara Hadid Architects. She joined Sara Hadid Architects in 2007. She has been there for 17 years, and she's played a pivotal role in major projects like the BEAH headquarters in UAE, and as lead designer in the Haidar Aliyev Center in Azerbaijan. I hope I'm saying that correctly. Obviously, Sara Hadid Architects are known for their pioneering in the technology pioneers and the use of technology in their designs. So please welcome Sara. There you are.
Thank you very much. Thank you very much. It's a pleasure to be here today. I wanted to focus on the dynamic relationship between design and technology through the lens of some of the projects we've developed as Sara Hadid Architects over the years. Architecture has always been a space where technology and design, they come together. So sometimes both vision pushes technology to move forward. At other times you see technological advancements open the door to new design possibilities. And I would like to run through some of these examples from the evolution of the office. So from the very early paintings, Zaha challenged graphic space, the way in which architecture was described at the time through plans and sections only. She was constantly exploring distortion of geometries, understanding of volumes through multiple perspectives, and creating a new understanding of architectural space through dynamic forms, moving away from the orthogonal plane only. In the early years, obviously, the work of the practice was seen very experimental. So the vision was there, and it was setting the groundwork for what happened next. But technology needed to catch up and was not ready yet. And it required a lot of experimentation, a back and forth process between the physical models, the paintings, the drawing board, eventually with the 3D software that resulted into the first completed project of the practice, which was the Vitra fire station. From that point onwards, that energy, that culture, it continued in the projects, and towards the late 1990s and early 2000s, technology had started to evolve. The digital tools were more readily available, and this is an image of our one of the first renderings of our Maxi Museum in Rome, which demonstrates basically that we started experimenting with more complex geometries at the time, and the introduction of curves and splines in the digital software really opened the door to explore dynamic forms and fluid forms in ways which were not previously possible. So this project completed in 2009, and this whole new approach opened the door to a whole set of new projects. As the projects evolved and we got more control over the tools and over the geometries, we started to move away from the earlier surface manipulations, and the projects the surfaces, the geometry started to become more refined and fine-tuned based on very precise parameters such as structure. So this is a construction photo of our Aquatic Center project in London, and you can see not only it was about aesthetic elegance, but finding the most optimal structural solutions and integrating the different aspects of design became fundamental. So this project was completed in 2011. And we start thinking through the envelope, like how you deepen the curve, create extra shading inside, open them up, create extra light within the spaces, and integrate the performance with the aesthetic, respond to environmental factors, passive design strategies, how the volumes are defined, placement of the courtyards, optimizing natural ventilation, optimizing shading within the spaces, in our Kapsark project, which is in the very harsh climate of Saudi Arabia and was completed in 2017. But the main turning point was the advancement in fabrication technology. It really opened the door for us to look at architecture and fabrication as an interconnected process. And this was quite essential for us to move from the image on the top, which shows one of the very early renderings of Haydar Aliyev Center project, to the image in the bottom, which is the completed project in 2012. It was, of course, about the new tools, but more importantly, this new way of thinking and framework of thinking that allowed us to innovate at the intersection between design and fabrication, create a more seamless connection between the two of them. With every project, there's so many layers that need to come together for a project to be realized. And with a project of this complexity, of course, from the early sketches, close collaboration with the engineers, optimizing the structure, understanding of the geometries, the surfaces, the material, its properties, limitations, how that translates into how we panelize the surfaces. And of course, like in terms of like the construction side, the concrete structure, the assembly of the space frame, the weatherproofing system, which followed the 3x3 meter grid to ensure efficiency and ease of installation, the secondary steel, and the rain screen. And this is not purely about the parametric design, but also, like any point in history of architecture, if we look, it's also the material of the time, the material innovation. So in the case of this project, like the use of GRP, GRC, glass reinforced plastic, glass reinforced concrete, opened the door to new opportunities to create these fluid and dynamic forms. And on the top image, you can see one of, we had to go through rounds and rounds of analysis and optimization of these surfaces, basically digital modelings of flat panels, versus, which you can see in green. Obviously, you want to increase the amount of them. They're easier to produce versus the single and double curve panels in red and green. And this analysis and optimization, then it was linked to these spreadsheets. Each panel type was indicated there. Each panel was tagged. And the information was eventually transferred into unrolled and documented panels shared with the specialist consultants and the fabricators for the next level of definition and realization. And what is important with this project is this is pre the time. Nowadays we have generative design tools, we have different plugins and Grasshopper and all that integrated into the software. So readily available to architects and designers to integrate within their design process. This project, which was completed in 2012, but it's pre that time. So we had to develop bespoke coding and solutions internally to be able to reach this level of optimization. And it definitely required a higher level of rigor and collaboration internally and externally to achieve this level. Nowadays, these software are readily available, and what it means is like we get to test options with complex geometries at fast speed, really fraction of the time, look at optimizing structures, run different simulations, and it creates a high level of productivity, which leads to new levels of boosting creativity and innovation in the work that we do. Before I go over some of the research work we've been developing over the past couple of years, and more recently, I'm going to show this last project, which is one of the more recent projects completed in 2022, and it links a lot of the points I mentioned with the previous projects together. So it's a project that has been inspired by its landscape as an array of dunes. It's in the desert landscape of UAE. And one of the main most important elements with this is sustainability was an integral part of the project, and it was integrated into every aspect of the project, from the geometry to the formal composition of the spaces to the MEP design, lighting design. And I'll explain some of the passive design strategies to explain how that all came together. So volumetrically, first of all, the volume is responding to the program inside. So you have the most public end of the building, the visitor center, in the north, the most private end of the building, the administrative zone and open plan offices in the south, and then the middle volume, or so we call it dune, in the center, which is public areas on ground floor, management areas on level 1. And these dune-like geometries, they split, creating skylights above the open plan offices, creating glazed facade to the management areas on level 1. At the same time, they start connecting, creating these 2 central courtyards, helping with natural ventilation, maximizing natural daylight within the spaces. We have large overhangs around the building, which create these self-shaded glazed facades. So this building, it's responding to its climate. We only have 9% glazing here, actually. But if you look at the interiors in different months, different points of the year, different times of the day even, the interiors are really flooded with natural daylight through these different considerations. And the selection of the material, it is comparable with the RDEF project, happened about 10 years after that. In this case, of course, the material helps increase the building thermal mass and dissipate heat away, but what is important that we changed the approach here. We use fully triangular, completely flat panels, and we had to meticulously design the geometries to ensure that these fluid geometries can be achieved with flat panels, which were locally produced and easily handled to the project site. And last but not least is the technological aspect with the project, apart from what was integrated into the design process. One of the primary use cases of technology is to create a seamless experience for visitors and staff. And here we have smart meeting management systems, virtual concierge, but on the health and well-being side, a more important element is the environmental sensors throughout the building. Through them, we're learning from the preferences and occupancy patterns within the building to create a more comfortable and more efficient and more sustainable building. So really looking at a building like a living lab, which is constantly drawing on this data and becoming more efficient over time. As you see with all the projects, research and experimentation is an integral part of what we do, and we're constantly looking at emerging technologies, material design methodologies through our different research teams and through the projects that we develop. And the first research project I wanted to show is a collaboration between our computational and design team and ETH Zurich, and it's a footbridge, 16 by 12 meters, and it has been constructed using concrete, 3D printed concrete blocks. And these blocks, as you saw from the first bit of the video, they've been printed using advanced robotics, and they are dry assembled, so there's no mortar, no glue. Strength is achieved through the geometry, and it offers the opportunity to significantly reduce the amount of material. Another area of research that we've been looking to, and in response to the growing digital interconnectivity, is the metaverse side of projects. And this is a virtual gallery we developed for Art Basel Miami in end of 2021. And these metaverse platforms are becoming a place for social interaction, and I mean, leading to the pandemic, there was a lot more effort in this grounds, but the research continues, and it really merges the virtual and physical world. We use analytic tools in understanding the user's experience within the different spaces. Through VR, we take advantage of it in our design process to navigate within the spaces, but also in how we present the projects to our clients. We have integrated tools using AI within the design software that allow us to look at updates live in live visualizations, and more with our clients, With the enhancement in AI, the expectation is to have high level of productivity and share information. And through the use of algorithms and tools, we look at optimizing the floor plates, position of atriums, placement of cores, but look at connectivity, collaboration within the spaces, and finding the most optimum arrangement within different spaces. We more and more are looking at agent-based simulations, basically looking at how people interact within a space. Like, I mean, you can see here the movement history map, the sound map, vision map, and this data is leading us to create, like, let's say just with the workspace, these very flexible, self-evolving workplaces, which rather than waiting for the next refurbishment to actually rearrange the space, it gives us the opportunity to look at adapting the spaces to the user's requirements and the occupier's requirements in any period of time that is needed. Of course, these adaptations need to be implemented now. Soon, I'm sure there will be robotic workstations and opportunities for them to basically autonomously adapt and rearrange. We have been looking at training our own AI and developing our own AI, feeding in information from the work we are doing, circling back to the early paintings that I showed at the start of the presentation, and generating data out of it. So these last 3 images are actually generated paintings from that sort of database. And AI is allowing us to, at high speed, fraction of the time that we had before, develop these unique spaces. And what is instrumental with it is it creates a high level of efficiency, a high level of productivity, which always links back to the creativity side and the innovation that we've been discussing so far. So this ongoing dialogue between design and technology, it drives us forward with what we're doing. And I'd like to end with this quote from Zaha, that there should be no end to experimentation, which is a guiding principle in what we've been inspired to do and what we continue to develop. Thank you.